Today we'll learn instantaneous center of rotation, and before discussing that particular instantaneous center of rotation, I'll let you know few basics which I'm gonna use in this particular topic. Okay, what are those basics? Motion. We all know what is motion, but I want to discuss the types of motion which we will be dealing with. Okay, so in our context, the syllabus which we have, for that the important motions are this. First is this translation, that can be of two types. What two types? One is rectilinear translation and the other type is curvilinear translation. Now what are those rectilinear translation and curvilinear translations? Suppose one link is there. Like this is your link AB, and it is moving in a straight line. Okay, fine, it is moving in a straight line. Like that, every point on this link is moving only in a straight line. Suppose this was the initial position, and now this is the final position of your link. Okay, that is at time t equal to t. Now what is important here, that every point on the link has traveled same distance. Like point C is traveling to point C dash, final position of point C. Point D moving to D dash, final position of point D. And the thing is, these lines are parallel to each other. What are those lines? Trajectory of the points situated on the link. Those velocities are parallel to each other, and this is the final position. This kind of motion is translation and rectilinear translation. Okay. What do we mean by curvilinear translation? Suppose that same link is there and it is moving like this. Link is there and it is moving like this. Got it? This is point A, this is point B. At any other situation, if you want to check, like t equal to 0 it was here, t equal to 2 it is here. Okay, so this is not a straight line, though this is a curve. The position of point B situated on the link is B dash after time t. The position of point A is A dash after time t. So what is happening here? The link is moving along a curved path, but the important observation of this particular path is that all the points on the link are moving along the same parallel path. This path of C, final position is C dash, this black line is the path of C, and it is parallel to the path of B as well as parallel to the path of A. So if all the points are following the same path and the trajectory is always parallel to each other, this is a curvilinear translation. Okay, fine. We are familiar with curvilinear translation, no issue with that. Now, after translation, one important motion is rotation. Okay, so this one is pure translation or translation. Next is rotation. After this translation, motion is there. Second motion, that is pure rotation or only rotation, that is there. This is one important motion, and with this pure rotation, what we can observe, that any body, suppose that link was there, A, B, the same link is there and it can rotate about any center. The center could be any point. It can be B, it can be A, it can be any other point situated at this link, maybe C or some other point, maybe D. That could be center of rotation. What I mean to say, the link can have any point which can be the center of rotation, and this link is rotating about that center only. Okay. So some general cases, suppose this link is rotating about point B, then what will happen? If link is rotating about point A, then what will happen? If link is rotating about A, then you can easily see that some kind of circular trajectory will be formed there. Some kind of circular trajectory will be found there, and you can see that when it will rotate with some angular velocity. It will rotate with some kind of angular velocity. Now, what do we mean by angular velocity? It's very simple. It can be written as like d theta over dt. What is d theta over dt? With respect to your center of rotation. In case this is our center of rotation. This is our center of rotation. In case this center of rotation, and suppose this was the initial point V, and in dt time it has covered this particular angular displacement. Okay, this displacement is nothing but d theta. So we can write this angular velocity as d theta over dt. Okay, now but there are few important things we need to observe. What are those? Those are like, if we check the velocity, okay fine, but where? At so many points on the link. If we check the velocity, what we can find is, like if there are so many points, like CD I have mentioned, suppose there is some other point E also, and this center A only, then what we can see, the trajectory of these points. This is E, this is C, and this is T. Final position will be like D dash, C dash, and E dash. Okay. Now, one important thing is that angular displacement of all the points on the links are same. Angular displacement, okay, d theta. You can see that B dash, how much angular displacement is there? D theta. E dash, how much angular displacement is there? D theta. Same is the case with C and D also. Okay. So C and D, angular displacement d theta only. Okay. How much time it has taken from moving from initial to final position? Dt time. Okay. Now look at this. Every point which is in angular motion can be defined in terms of angular velocity and linear velocity at the same point. This complete link is supposed to rotate about point A with an angular velocity omega. But the linear velocity, that can be expressed as V is equals to radius times omega. Okay. What is this V? This V is nothing but the linear velocity. Linear velocity of what? Linear velocity of any point on the link can be expressed as radius multiplied by omega. Now this omega is constant for every point. You have already seen that in dt time every point has covered this particular angular displacement d theta. So angular velocity is constant for each and every point, but linear velocity will vary as per the radius. You want to see? I will show you how. See, suppose I am talking about point B. Suppose I am talking about point B. Now what will happen? If you want to take the velocity of B, how you can write? You can write radius of B multiplied by omega. Now what do we mean by radius of B? Radius of B is nothing but the distance of point B from the center of rotation. Radius of B is nothing but the distance of point B from the center of rotation. This is the point B and this is the center of rotation. So this particular distance, I can say this distance is nothing but RB. This. Okay. Now, if you want to calculate velocity at point E, we can easily write the same. Velocity at E is equals to RE multiply by omega. This is what? Velocity of E multiply by radius of E. What do we mean by radius of E? Same. The distance of point E from the center of rotation. So that is nothing but this particular distance from E to center of rotation, that is RE. Same is the case with velocity of C is equals to, it can be written as RC times omega. Any point we can take up in this link and we can find the velocity at that particular point as product of angular velocity and the radius of that point. Okay. If these velocities are equal or not, we can easily judge. No problem. How? By the expression you can see that velocity is linearly proportional to radius. I'll show you practically how. Look at this. What is happening? These points are taking same time dt, but they are traveling distance, different distance, linear. If you talk about this circular arc, you can easily observe, though angular displacement is same, but the arc length, the linear velocity with which they are covering this arc length should be higher for the case of B with respect to any other point which is below B, E, C or D. How? Why? Because this particle has to cover a greater distance in that same particular time dt, so it should have a larger velocity, linear velocity, so that it can cover this particular arc in same time in comparison to any other point, suppose E or C. Here the velocity will be a slightly less than velocity any other point which is above this. Why? Because this particular arc length will be less in comparison to point situated above it. Any point which is situated above it will have higher arc length. So definitely you can observe this practically, that velocity, linear velocity will be higher if we move from the center. Okay. And those velocities will be decreasing if we move towards the center. Okay. That's okay for now. And after this pure rotation, there is a combination of these. Actually, that is called plane general motion. After this pure rotation, what we can say, and this is normally very well general plane motion. Okay. What is this general plane motion? Plane motion we are talking about with respect to our syllabus. But this general plane motion is if the object is not in pure translation, neither in pure rotation, then what will happen? Then definitely it is following some general plane motion. Okay. How we can understand this general plane motion? We can understand this general plane motion so many times. For example, I am giving you, like, if there is a rigid bar or ladder, you have seen this kind of stuff many times. This AB, this is the ladder which is resting on this. Okay. What if it is not in equilibrium? It will move. How it will move? If this end will move in this direction, this end will move in this direction, then what should be the motion of it? Suppose this is the scenario at t equal to 0. Okay. After some time t, what will happen? What will be the position of this particular link? This particular link will be somewhere here. This is the final position of the link, which we can say A dash at t equal to t, which we can say B dash at t equal to t. So this particular motion of this AB link is neither comes under translation nor comes under rotation. Basically, it is the combination of both translation as well as rotation. You want to see how? Look at this. This motion we can divide as, first, we can divide this particular motion as pure translation. What will be that? See, initially it was given like this. Initially it was given like this. This was A and this is B. Now, all these points will move at this distance. Okay? All this point will move at this distance. So, it should be the position of your link. A dash, and this is some other position, we calling it B1. Okay? Now what is happening? After moving this particular part, now here every point is in translation only. This is called pure translation, which we have seen. Next, what will happen? Now, this particular link has to rotate. Rotate about what? Rotate about point A. You see how? See. After this, what will happen? After this, what will happen? After this, rotation will happen. This and this. This was the same. Now, this link will rotate from here to some position like this. This is B dash, the final position. This is B dash. This is B1. This is B dash. And how will you reach B dash? First translation and then rotation. Rotation about which point? Obviously rotation about A dash. Then this particular link, from here it will move like this. And this is your final position equal to. So we can observe this, that this plane motion can be divided into pure translation as well as pure rotation. Okay. I will tell you with the help of another example. And what is that? Have you seen a disc rolling? A disc rolling along a floor. How that disc rolls along a floor, I'll show you. Suppose there is a disc and it is under pure rolling. And this is the example of this general plane motion. Pure rolling is an example of general plane motion. How? Because those points A and B situated on this particular disc will be, now this is the initial position at t equal to 0. What will happen at t equal to t? T equal to t, it will be somewhat like this. Now, this is the position of center, but B point will be somewhere here instead of this earlier B. Okay. So, how this motion, this general plane motion, this is neither translation only, this is neither nor rotation only, but the combination of both. How we can see? Suppose, what happened here? Initially, what is happened here? This particular disc has translated from here to here. Okay, this was the first step. This disc has translated, and thereafter, what happens? Thereafter, translation. This disc has rotated this much angle. This d theta, this much angle. The disc has rotated. So the point B has been shifted to point B dash. Okay? Got it? Now, if you break this particular motion, then what we can see like this? It is like this, as if the disc was in pure translation. Here it was pure translation. Pure translation means all the points on this particular disc are in same motion. They are moving with same velocity and they are moving along same line of action. All the lines will be parallel to each other. What lines? The velocity. Direction of velocity at this point direction of velocity, at this point direction of velocity, at this point, as well as the magnitude of velocity. Units are obviously meter per second. I am taking SI units. V, and V. These are the velocities at different points. You can take any point. This point is also V. This point is also V. Every point you will get the same velocity, and these lines are parallel to each other as it is the motion. Pure translation. Now, if we add, what we can add? If we can add pure rotation into it, how the pure rotation will happen? You know this. No. For pure rotation, we need some center point. Suppose there are 3 points. This is point B, this is point A, and this is point C. Now, what will happen? This is point A, this is point B, and this is point C. This disk is rolling forward. This disk is translating forward, and this disk is rotating clockwise. See how this disk is rotating clockwise, such that this point will be having velocity V. This point will be at rest. As you know, center of the circle has zero linear velocity. Why? Because what I told you, that V is equals to R omega, this becomes 0. Where? At the center only. At center, radius will become 0. So linear velocity will also become 0. So this point is at rest, and this point will move with V velocity, but in this direction, leftward. Okay. Now, if we club those two velocity, definitely we can club, because the combination of translation and rotation is nothing but the plane motion. Okay. Pure rolling of disk. So what we can write here, as a result of these two motions, our disk will be appeared as if, now see, this is the point A, this is the point, which point? B, and this is the point C. Now what will happen? If we club these two motions, we will get that velocity at point B is like this. What is the magnitude? 2V only. Okay. Here V, here V. Club to 2V. What is happening at the center? At the center it is V meter per second. It is 0. So this is V only. And the important point is this point C. What is happening at this point C? At point C, this velocity in forward direction and this velocity is backward direction. Okay. So if we club these two, what will be the resultant velocity at point C? It will be 0. 0 only. Okay. So at this point, our velocity will be this. 0 only. Okay. Now, as I have already told you that this is pure rolling only, है ना? Without slipping. And it is possible only when these point will having same magnitude of velocity. Otherwise, what will happen? Suppose if translatory motion, the velocity of point C is not equal to R omega. Like in this case, V is equals to R omega. We know this. If this velocity is not equal to R omega, what will happen? Whether it will be higher or it will be lower. Suppose if this V is greater than this R omega, then what will happen? Then this particular disk will not be in pure rolling. This disk will slip in forward direction. And if the magnitude of this point in pure translation is less than that of R omega, then what will happen? Then this disk will slip in backward direction. Okay. But as I have already told you, this is the case of pure rolling. So we are getting this point at 0 velocity. And we can assume that this particular object to be in motion about this point. You want to show how? See, I'll tell you. You have two velocity vectors. Velocity at point B, you know, 2V. Velocity at point A, you know V. and the direction of those points you also know. Okay. So if you want to find the point which is at zero velocity, how can you find that point? Okay. Please note it very carefully. This is important. You just need to draw two lines. What are those two lines? Those two lines are passing through the point at which you know the velocity. Okay. So in which case, this is B and A. So we just need to draw a line which is passing through A and B, the point at which we know the velocity or we need to determine the velocity. Those points are A and B, and we have drawn a line from this. Now we need to draw another line. That line will be nothing but the magnitude of velocity we know at these points. So we need to draw a line like this. This is velocity vector at point B. This is velocity vector at point A. And we need to draw a line which will pass through tip of these vectors. And the point at which this line intersects the previously drawn line will be our center or the point of zero velocity. How we can check that? You already know this point is at zero velocity. After construction, we are coming to know that this line is intersecting previous vertical line at this C point only. Okay. Now, the velocity profile, if you talk about the velocity profile, you can see that velocity is continuously decreasing if we move along this particular point of zero velocity. And after reaching at point, you are getting zero velocity. Okay. Now the concept of instantaneous center of rotation is nothing but this whole disk is supposed to rotate, pure rotation. This disk is supposed to rotate about this point of zero velocity. Okay. You want to see how? See this. This can be assumed as if this particular disk is rotating in this circle. Look at this. Having this particular point as center of rotation. Center of rotation. How we come to know? Because we know it very well in the previous concepts of pure rotation that center in pure rotation is at zero velocity. So the velocity of this point is zero, and look at the profile also as I have discussed earlier. This is the topmost point, radius is complete from C to B. This is the farthest radius. So this point is having largest magnitude of linear velocity. Linear velocity is somewhat extreme in this particular point at B. If we move toward the center, then what is happening? Velocity is decreasing. If we move away from the center, what is happening? Velocity is increasing. So we can assume that this particular disk, complete disk, is in pure rotation about this point. And this is the advantage of this method, that if we are able to determine the instantaneous center of rotation, in this particular case, this particular point, center of rotation, is called as instantaneous center of rotation or IC. What is the advantage of this? If we are able to determine this particular point, then very easily we can determine the velocity at any point on the body. Okay, it could be anywhere. We can easily determine it, and we will show that particular case in following examples. So let us take an example. Let me take an example. I'll tell you how to find this instantaneous center of rotation and how it is helpful to determine the velocities at various points. Okay. So if we take a roller which is in general plane motion, okay, if we take a roller which is in general plane motion, how? This is the roller. See, this is the roller. Where it is? It is kept like this in between two plates. What are those two plates? Those two plates are nothing but the conveyor belts, and the roller is kept in between. Now, the velocity of these belts are given like this. In this direction it is moving with 5 meter per second. Suppose in this direction it is moving with 3 meter per second. Okay, this is given to you, and this is point A, this is point C, and this is point B. Let it be, and this is center. Point C I am mentioning center. What you need to determine, if the diameter of this disc is given as, diameter of 1 meter. Okay, then what you need to determine, you need to determine the velocity at the center. That you need to determine. Okay, you got my question? This disc is in between two conveyor belts which are moving with 5 meter per second and 3 meter per second, and the diameter of disc is given, and then they have asked what should be the velocity at center. At this point, what should be the velocity? Okay, same question can be given to you as, if the disc is same, this upper belt is same, it is moving with same velocity also, 5 meter per second it is moving, and this belt is same, but the problem is that this belt is in backward direction. Motion of this belt is in backward direction, 3 meter per second. Same case, this is the case 1, and this is the same case but slight different. This is case 2. The difference is only with respect to velocity at point B. This is A, this is C, and this is B. The only difference is with respect to velocity at point B. Now, what we can do to get velocity of center point? Okay, we can use instantaneous center of rotation method. If we are able to determine the instantaneous center of rotation, then definitely we can solve for this in seconds. Okay, how to draw the instantaneous center of rotation I am going to tell you with the help of these two examples. Now focus. We take this disc. Okay, we take this disc. See, I have taken this disc. This is that same disc. Okay, what are the given points? The given points are like point A and point B. At these 2 points, velocity is given to you. So you just need to draw velocity vector as these 2 points. And as this is semi-graphical method, you should be a little careful about the vectors. This is 5 meter per second. Obviously, 3 meter per second should be a slightly less than this 5 meter per second. If this is 5 meter per second, I can assume this to be 3 meter per second. Okay, this is slightly less than 5 meter per second. Now, what I told you, we need to draw lines. Which lines? The points of known velocity. So these are the points. Okay, or we can say end point of vectors. We need to draw a line, and this is the tip of vector. We need to draw a line. Okay. Now you see the point of intersection. This is the point of intersection which is known as instantaneous center of rotation. At this point, velocity will be 0. How? Focus once again. You have already seen this, but let me show you again. See, the velocity profile. The velocity is highest at this particular point A, 5 meter per second. Next is, it is decreasing somewhat. You can clearly observe that length of this arrow is slightly less. It is decreasing, and it is decreasing, keep on decreasing after B. And what is at this point? At this point, velocity becomes 0. Okay. So this is your instantaneous center of rotation, and look at this. This whole length from my elbow is at instantaneous center of rotation, and my tip, this is at A, and this complete motion is pure rotation about my elbow. Look at this. In dt time, it is rotating like this. In dt time, it is rotating like this. So this total motion from IC to A can be assumed as a pure rotation. Okay, this is a pure rotation. Now we come to how we'll find the velocity at point C. It's very easy. If you determine this IC, now you can write equation. Equation for what? Velocity of any point. Suppose this is A, velocity of any point will be, just join that point with IC. I will write it I only. That I, instantaneous center of rotation A, the velocity at this particular point A you have to determine, or it is given to you. So velocity at A will be AI into omega. Velocity at B is equals to BI into omega. Velocity at point C should be equals to CI multiplied by omega. Like this we can do. Got it? Now, any other point, I told you na, any point. Suppose this was your center, but this is some other point E. Now, what you can do, if you have to determine the velocity of point E, what you can do, just join this point with your I center. Draw a line like this, and definitely you can get the velocity of point E also if you find this particular distance and multiply it with angular velocity. Okay, for this particular angular rotation. Got it? So these many equations are there which we can use, but how to use these equations I'll also tell you. That velocity at A is given to you, velocity at B is given to you, so we can use these particular equations, like velocity of A is given to you as 5 meter per second. Velocity of B is given as 3 meter per second. So now what we can do, we can divide these two velocities. Very easy, है ना? We can divide. What will be the advantage of this division? The advantage of this division will be only that we can eliminate this omega. Got it? We can eliminate this omega because this is unknown to us. And we can get a relation between AI and BI. That will be helpful for us. How? I'll tell you. If we divide like this, what we will get? We will get that with this relation we'll get AI is equals to 5 by 3 times of BI. Okay? This is one important relation because we need to find this CI now as well as omega. We can find omega if we are able to find any of the distance. If you find AI, then you can find omega. If you find BI, then also you can find omega. So our objective is now reduced to find these distances because for VC we need to find this CI. So for that I was looking for a relation between these lengths and I got this first relation. Now second relation is what? Look at this distance very carefully. Okay. What is given to you? The diameter is given to you. That is 1 meter only. है ना? So diameter is like from this to this. This AB is nothing but diameter only. है ना? Then this AB can be written as, look at it very carefully, AI minus BI, isn't it? Look at this. AI complete length from here to here and BI this particular length. So distance remaining will be AI minus BI. This total is A to I. This is AI. Okay. This A to I. Now this point is somewhat BI. If you subtract AI minus BI, if you subtract BI from AI, what you will get? The remaining length will be nothing but diameter, that is AB, that is 1 meter. Okay. So now we can write this as AI minus BI is equals to 1 meter. Okay. So we have two relations. AI is equals to 5 by 3 BI. We can put it over here also. 5 by 3 BI minus BI is equals to 1 only. Okay. What is this? This is nothing but BI is equals to, how much it is? BI is equals to 1.5, isn't it? This will be 3. 5 BI minus 3 BI, 2 BI equal to 3 and BI is equals to 3 by 2 or 1.5 meters only. This B to I is 1.5 meters only. Okay. Now, when you got this particular BI is equals to 1.5 meters, can you find out omega? Obviously, you can find out omega. Okay. You can definitely find out that omega. How to find that omega? Just put this particular BI in this equation. Okay. In this equation. What is this? 1.5 into omega is equals to 3. So omega will be how much? 3 by 1.5. That is nothing but 2 radians per second. This is the value of omega you have got. Now our task is to find out Ci. If we want to find this velocity, Vc, half part is done. You know the velocity of omega. Now what is this Ci will decide the velocity at point C. So how to find this Ci? For this Ci, it is very easy. Now you know the distance from I to B. This Ci can be found out by two ways. What two ways? Two ways are like this. We can write equation for Ci as, if Ci is, look at it very carefully, it will help you, Ai minus Ac. Look at this, what I have written. This is complete length. From here to here it is Ai minus Ac. You can write this. Ac is nothing but the radius of your disc, and that is half meter. है ना? Next, you can write Ci equals to, see, Bi, you know, this is Bi. What you need to add? You need to add this Cb. Cb is also nothing but the radius of your disc. Okay? So now we can write this Ci as Bi 1.5 plus this Cb is nothing but 0.5. So this Ci will be 2.0 meters. Okay? Now we have got all the important things. Look at this. In order to need this velocity at point C, we want to calculate what is Ci and we want to know what is omega. And we have got both the things. This Ci is nothing but 2 meter and this omega is nothing but 2 radian per second. So now we can easily calculate velocity at point C, which was asked. Velocity at point C is nothing but 2.0 into 2. That is 4 meter per second. This is the final answer for velocity at the center in case 1. Got it? This is the final answer. Velocity at point C is 4 meter per second, and it is clearly observed. Look at this. This point 4 meter per second we are getting, है ना? Isn't it? Now look at this. This is 5 meter per second. 0.5 meter you are decreasing and it is 4 meter per second. Again 0.5 meter you are decreasing. This is 3 meter per second. Every 0.5 meter velocity is decreasing by 1 meter per second. Got it? Now look at this. At this point velocity is 3 meter per second. Now this distance, how much this distance is, you have already calculated. That these are the practical observations. Whether your answer is justified or not, we can check it from the actual diagram. What is the significance of this answer and what is the significance of this method? We can see that, look at this. Velocity at point B is 3 meter per second and every half meter velocity is decreasing by 1 meter per second. So this Bi we have calculated as 1.5 meter. Now look at this. 1.5 meter distance we are coming again downward and velocity will be decreased by 1 meter per second for every half meter. So that is why we are getting velocity is 0 at this particular point. Got it? Now quickly moving to case number 2. This was the case where velocities are same in magnitude as that of previous case, but the velocities are not in same direction at point B. So this is the only difference with previous case, and now we'll see how to approach this particular problem. Okay, so the result for this previous question I will take as reference so that we can compare later on when we will get the result for this case 2. Okay, this was the case 1. Don't get confused. This was the case 1, and now I am drawing for case 2. Okay, this case 1. How to start with? As you already know, how to start with? We should start with a circle. That is our disk only, nothing. And then what we need to do? Then we need to draw the important points. Which points are important? At which the velocity is given to us. So this was the point having 5 meter per second velocity. Which point? Point A. Okay. Now, velocity of this point was also given, but in this direction, and this is nothing but 3 meter per second, and the point is not C, point is B. Okay. Now, as of now, I have already told you how to draw the instantaneous center of rotation for this. Just draw a line perpendicular to velocity and passing through these points of known velocity, or the points at which you need to find the velocity. Okay, this was the first case. Now the vectors are with you. Just draw another line which passes through the tip of the vector. This line is passing through the end of the vector. So that line could be drawn like this. You tell me whether this line will be passing above the center or below the center. Obviously it will pass through below the center. Why? Because this is having higher magnitude than this. If these two magnitudes are equal, then what will happen? Then this particular line will pass through center. If this was higher in magnitude, 3 meter per second ki jagah pe, instead of 3 meter per second, if it would have greater than 5, then this line should have passed through above this center. Now in this case, it will pass through like this only. Okay, instead of this 3, if it would have given like 6 meter per second, then definitely this line would have crossed this center and above it would have been passed. But in this case, look at the velocity profile also. Velocity profile is like this. Velocity is keep on decreasing as we reach toward the center, and this is not the instantaneous center of rotation. This blue color point is point C. This is the velocity of center of disk, but not the instantaneous center of rotation. Do not get confused with it. Instantaneous center of rotation will be the point where these two red lines I have drawn. What are those red lines? Those lines are intersection point of your velocity vectors in such a manner that end point are connected with one line and the tip is connected with the help of another line. So the intersection of these two lines will be your instantaneous center of rotation. This point is your instantaneous center of rotation. This is your IC, and you can observe that velocity will be 0 at this particular point, instantaneous center of rotation. After that, what will happen? The velocity will change its direction and keep on increasing. Okay, it will keep on increasing. So here again, we have to use the velocity at center point. Okay, so we can write equation for that also. Velocity at the center point can be calculated as, velocity at the center point will be nothing but Ci multiplied by omega. Again, same thing now. It's very easy. Vc is equals to Ci into omega, and we can use those relations also. What are those relations? Those relations are Va is equals to 5 meter per second, and this Va can be written as Ai multiplied by omega. Got it? Is equals to 5 we can write. Same way Vb is given as Vi multiplied by omega is equals to 3. Got it? So we can again divide these two like this. What we will get? Now we will get this. Ai is equals to 5 by 3 times Bi. This is one important relation, and I have already told you why this is important, because we need to find this distance out. What is the length? Ci. That we need to find now. So for that we need some relation between these distances. What is the next relation we can use? Obviously, look at this very carefully. What data is given to you? The diameter of disk is given to you. It is like this. Total A to B. 1 meter it is given to you. Okay. Next is, this is the point, your I. I center of rotation, instantaneous center of rotation, both are same things. This is given to you. So what we can do? We can break this distance. This is nothing but Ai, and from here to here this is nothing but Bi. So now you see the summation of Ai plus Bi. Summation of Ai and Bi will be nothing but the diameter of the disk, AB. So we can write here Ai plus Bi is equals to 1. Got it? Okay. Now if you put Ai is equals to 5 by 3 Bi, then what we will get? We will get this. 5 bi by 3 plus bi is equals to 1. Okay, what we will get if we put this particular part, we will get as the result of this will be nothing but bi is equals to 3 by 8 meter. Any problem? Simple mathematical expression for this length. bi is equals to 3 by 8 meter. Okay? Now, what is ai? ai is nothing but 5 by 3 times of bi, and bi is 3 by 8. So this is, you will get as 5 by 8 meter. This ai is 5 by 8 meter and this bi is 3 by 8 meter. Okay. Now, why do we need these distances? Because we want to calculate this ci, isn't it? We have to calculate this ci. Now look at this. We know the value of ai, we know the value of bi. Now we can easily calculate the value of ci. How we will calculate? For calculating the ci, what we need to do? See, this is c and this is I. Very small distance is this. This is ci. This particular length is nothing but the ci. How to find this ci? Again, this ci can be found out by two methods. What are two methods? This ci we can write as, look at this, we can write as AC. This is AC. No, we should write AI minus AC. Look at this. Ci is equals to, this distance is equals to, this particular distance is equals to this AI minus AC. We will get this remaining distance. One method. Next is, we can write this as this. Ci particularly, how we can write it? This Ci can be written as, that you tell me. This is sufficient. This Ci can be written as Ai minus AC, and this Ci can also be written as what? This particular length is your radius now, from C to B. This is your radius only. This is your radius. So this radius minus what? Minus this Bi. So we can write this Ci as Cb minus Bi. Like this we can get Ci in two ways. Okay. Now when we know the value of this Ci, it is very easy for us to get the value of omega. How? We know the Ai, we know the Bi. We can put any length in this particular equation. Suppose, now for this omega what we can do? For this omega, we can put the values in previous equations, like this 5 is equals to, in this equation I am talking about, this is nothing but, this 5 is equals to Ai, that is nothing but 5 by 8 into omega. So omega will be nothing but 8 radians per second. And if this omega is 8, now we can easily determine this velocity at point C. It will be nothing but Ci multiplied by 8. What is the value of Ci? Value of Ci is nothing but this Ai you have got 5 minus 8 minus 0.5. Like this, Ci is known to you, omega is known to you. You can find out velocity at point C in meter per second. So these were the two cases where instantaneous center of rotation got changed just because of one slight change in the problem. Two different cases were there. For this particular case, point A and B were moving in same direction. But in this particular case, point A was moving rightward, but B was moving leftward. It was the instantaneous center of rotation for the second case, which lies between point A and B, and this is the instantaneous center of rotation which lies outside point A, B, not on the disk but outside of the disk. But this is lying inside. On the disk it is. So instantaneous center of rotation would be on the disk, off the disk. It doesn't matter that where the point is, but it is assumed like at that particular point the whole disk is in pure rotation. Okay, I will give you one more example that there are so many questions which have been asked in GATE examination, but I will give one simple example initially where you can easily determine the instantaneous center of rotation like this. So I will tell you the questions. You can approach like this, and so many questions are there in GATE examination you can solve for. Okay, now see one very simple case. Actually there is nothing like simple or complicated. If you are thorough with the concept, you will feel it simple. If you are not thorough with the concept, you will feel as it difficult. That is why same paper, same question, some student might feel, oh, it is very easy, but some fellows may think like, oh, it's very difficult. It is difficult only by the time you are not aware with the concept. Once you learn the concept, once you know the concept, same thing might be very easy for you. So there is nothing like this is very difficult. No, don't make hype of that. No, there is nothing like that difficult. It will take time, it will take practice, and then thereafter the same thing will appear very easy to you. It's a matter of time only and hard work. That's it. Now see, here this link is given. Okay, the velocity at this point, suppose this is A and this is B. Velocity at this point is given to you. Velocity of A is 2 meters per second. At this instant, it is making an angle 60 degree with the horizontal floor. And velocity at this point has to be determined by you. Okay, where the length L is equals to 4 meters. What is this length L? This is nothing but the distance between point A and B. Okay, this is given to you. Now first you tell me how to approach this instantaneous center of rotation approach I am taking for solving this. There are so many approaches, but we are practicing for this particularly instantaneous center of rotation. Now look at this. I have drawn the same link here. Okay. Now you need to draw, what you need to draw? The velocities at which point is given to you. You need to observe those points. So velocity at A is given to me. I have drawn the velocity vector. This is nothing but velocity at point A, that is 2 meters per second. Now at point B, we don't know the magnitude of velocity, but definitely we know the direction of velocity. So what we'll do, we'll draw the direction of that velocity. This is VB and this should be the direction of velocity vector. Now what we need to do, just draw perpendicular lines. What perpendicular lines? To that particular velocity vector, and from which point? The point at which the velocity vector is known to you or you have to determine. Okay, so this is the point where we have to determine. We have drawn a line like this. Again, at this point it is given also, and we have drawn a line perpendicular to the given velocity vector and passing through the point at which velocity vector is given. Okay, so intersection of point is your instantaneous center of rotation. Okay, at this point it is given to you and lengths are also given to you. Got it? Now if you want to write, again same, it's very easy to write equation. How? Velocity of point B will be nothing but Bi multiplied by omega. Velocity of point A will be nothing but Ai multiplied by omega. Like this we can write only. Next, this is given to you, but you have to determine this. Then what we can do, just divide these two equations. What will happen? This omega will get cancelled out. Omega by omega, no need to determine omega because it is not asked in the problem unnecessarily. Why to determine omega? Now this velocity of V can be expressed as this Bi divided by Ai multiplied by Va. Now this Va is already given to you. This is given to you now. So we just need to find this bi upon ai. And from this particular diagram, are you able to determine this bi upon ai? Look at this very carefully. This is bi. Okay. This is ai. Got it? This is bi and this is ai. Now suppose this angle you assume as theta. It is already given in the problem, theta equal to 60 degree. But by the time I am assuming that this angle is theta. So can we write equation for this? Tan theta. It will be nothing but this height upon base. Tan theta will be equals to bi upon ai only. Look at this. So what we can do? Immediately we can replace this bi upon ai with what? With tan theta, that is 60 degree in this particular case. So we can write velocity of B is equals to tan 60 into velocity of A, that is given as 2 meter per second. So this is your answer for velocity of point B. Now look at this. From the point of view of gate examination, what they can ask? They can ask for this velocity even if they have not given the length of the rod. You see, is there any use of this length? It is just given to you but not required for the calculation of this VB. What they can ask you? They can ask you for velocity of any other point also. This is B. You have already calculated velocity at point B. In addition, what they can do in gate examination, they can make changes. They will ask you like this. Suppose this is some other point C. This C point is what? Midpoint of AB. Getting? Midpoint of AB. So velocity at point C can also be determined. How will you determine velocity at point C? Same thing. What same thing? Just this, locate this point C and draw it with this. Meet these 2 points I with C. So this is the point and the velocity, this is general theta I have taken. So this is the point C and velocity of point C perpendicular to the line CI can be determined with the help of that same equation, that velocity of C will be equals to Ci into omega. What it? Ci into omega. Again, no need to determine for this omega. How? Because this Ci and relation in between any other side Bi and Ai, if you are able to determine, then very easily you can find. Otherwise, you will need to find out this omega. If this angle is not perpendicular, then definitely you have to find this omega, and that you can find very easily because this angle is known to you, and then you will require this length. If you know this length, then you will find this particular height, what it is. If it is not given in the problem, then also you can attempt the same problem. How? Just assuming it that this length is given as L meter. And in terms of L, you will get the values of these lengths. They will get cancelled out. L will get cancelled out. So like that you can also attempt. Okay. Now moving on to next question. I'll give you some question from your one of the very important mechanism, slider crank mechanism. Okay. You know what is a slider crank mechanism? Slider crank mechanism actually an example, very simple example, but I can show you all 3 motions which we have discussed in the same mechanism. See how? Suppose there is a crank. This is your crank, and this crank is somewhat length is given. Suppose it is 60 mm given to you. Okay. This is the crank. This length is 60 mm. Now again, what will happen? It is connected to some slider. You know very well what is a slider. Slider is kept between this particular rigid support in such a manner that it can reciprocate only. It can have linear motion, translation to and fro. Okay. But this crank will always rotate, whether clockwise or anti-clockwise. This will rotate only. So if this is A, this point is A, some other point B is also there, and some other point C is also there. So what will happen? This particular link PC, it is subjected to general plane motion, and suppose the length of this is given as 240 millimeters. Okay. What is happening to this link? This link is subjected to pure rotation only. This crank will only rotate. No other motion possible for this crank. And what about this slider? This slider will always reciprocate to and fro. So this motion is pure translation. This motion is pure translation. Got it? This motion is pure translation. So in this case also they can ask you velocity of point B, velocity of point C, or angular velocity of point A. Those many things can be asked in the problem. So concept of solving these particular mechanism with the help of I center is like this. Okay. If this point B is to be considered, so what is special about this point B and what is special about this point C? Two things are special. This point B lies on this crank as well as this link PC. In both the links it is. So velocity of point B is same for both the links. How? See, if I draw these links separately, how I can draw? See this. This is the crank. Okay, this was point A and this is point B. So velocity, if this crank is rotating with some angular velocity omega c. Okay, angular velocity omega c, or you can write it as omega AB. This is the angular velocity of the crank. If this crank is rotating with this much angular velocity, then what we can find out? We can find out velocity of B in this particular direction only. And we have the equation velocity of B is equals to VA multiplied by omega AB. What is this? For this particular crank only, this is your instantaneous center of rotation, but this is pure rotation, so this is always not in this instant only. At any instant, this only be the center of rotation for this crank, which is fixed. So we can write this equation. Velocity of B can be determined by VA into omega AB. And this omega AB, they can give or they can ask. One thing. Now, this particular point C, which is on the slider. So, it is special about this point that this point is on the two links. It is on the slider as well as it is on the link BC also. So, what we can write here? If we want to show this slider is always in this reciprocating motion. For example, this crank I have assumed to be in counterclockwise rotation. Then what will happen to this point? This point, this slider, this will move in this direction only. Okay? And velocity of this point can be expressed as VC. Now we focus on this link, because in question they will ask for angular velocity of this link or the linear velocity of any point which is situated on this link also. So what is that case? The link BC can be drawn like this. Okay, BC can be drawn like this. This is B and this is C. This is also C. Now the velocity at point B, you know it very well. What is the velocity at point B? This same velocity will be at this particular point also. Now it is not necessary that this is perpendicular to this or parallel to this. That will depend on the data also. But what we know, it is, this velocity is perpendicular to the crank only. Got it? It appears to be 90 degree, but not necessarily this angle is to be 90 degree. Don't get confused. Okay? This VB we have drawn, and this particular point will have this velocity, that is velocity of C only. So what I am trying to say, I am trying to say that if velocity at this point is known to you, we can draw it on this link BC also. If velocity of this, any velocity, linear velocity or angular velocity is known to you, we can draw linear velocity of point B on this particular point also. But the concept is, this will be perpendicular to the crank only. Got it? Perpendicular to the crank only. If you are getting confused, I can draw it like this also. Draw it like what? Just this particular angle, it might be like this also. See this. Now it will be very clear to you because this orientation is appearing to be 90 degree. But what I am telling, that not necessarily this line is to be along this. See, velocity of B, I think now you understand. This is the velocity of B and this is the velocity of C. Like this will be the velocity vectors on this link BC. This link B and C. Got it? How to draw instantaneous center of rotation for these links? We just need to draw perpendicular lines from the points where we have velocities. So this is the same case. This is VC, completely horizontal. The line which is perpendicular to this will be like this. Somewhere here. But for this, if we draw a line like this, it will definitely go and intersect at this point. And this point will be your eye center. Got it? This point will be your eye center. Now, what if we have drawn this line as perpendicular? We know the distance B to I and C to I. Then definitely we can calculate, we can link those velocities as, now look at this very carefully, velocity of A can be written as AI omega BC. This is the link BC now. So we can write like this, not A, this is B, link B. Velocity of link B is equals to BI into omega BC, which can also be expressed in terms of crank rotation, that is velocity of B is equals to BA into omega AB. So this is the radius of crank. Got it? Where A is your actual center of rotation. At any instant, it will always be your center of rotation for the case of crank. But for this link, particularly BC, this particular IC is your instantaneous center of rotation at this instant only. Next instant, it might be somewhere else. But at this instant, this is your instantaneous center of rotation, and you can calculate velocity of B as BI into omega BC. So these two equations are very important because we are writing these equations for same point, but we are writing these equations for different links. This is your crank AB and this is your link BC. So these two different links are there, but point is same. This is very important about this particular discussion. Next, velocity of point C can also be written as Ci multiplied by omega BC. With the help of these two equations, you can find out so many things. The data will be given to you and they will ask whether velocity of point C, they will ask whether velocity of this point B, or they will ask whether velocity of this point, this is something else point. Suppose this is D point, this is D point. You can always calculate velocity of point D also if you are able to join it with the I center, and you can write equation like this. Vd is equals to Di multiplied by omega Bc. Like this you can also write. There is no problem. But it is not necessarily that angle is given to you or angle is not given to you. Suppose in this case I have shown you this is 60 mm, this is 240 mm. Got it? If they provide any of the angles, suppose this angle is 90 degree, then you can easily calculate rest of the angles. Those angles will help you to determine the lengths, different BI, different DI and CI. So these different lengths you can determine with the help of given dimensions and given angles. Got it? Now moving on to some other example, like one special case for this. This link is given in this orientation and this link can also be given as in some other orientation. Now the same question but at different theta. Okay, now see how it will be. Same question but with a different orientation, because that is the special case of instantaneous center of rotation. Now look at this. If the same crank, this is point A and this is the top point B and this is your link BC, which is like connected to this slider. Got it? So this was A, this was C, and the lengths are also given as this is 60 mm, this is 240 mm, velocity of point A. You can decide by itself if angular velocity is given to you. What they have given? They have given omega AB is equals to 10 radian per second. Okay, if the angular velocity of crank is given to you as 10 radian per second and the instant when this crank is completely vertical, at this instant they have asked you that what is the velocity of C. At this instant, what is the velocity of C? Now, how will you calculate the velocity of C? For velocity of C, what we need to do? We just need to draw the instantaneous center of rotation. But important point is, for what you need to draw instantaneous center of rotation? Because this point B is on crank as well as this link BC, and this point C is as well as crank and on this slider. So we'll take this particular link BC. We'll take up this particular link BC. Now this is I have taken, this is C and this is the link B. Got it? This I have taken. We just need to draw the velocity vectors and a line which is perpendicular to the velocity vector. So velocity at C, it is not given, but we know the direction of velocity. Look at this. At this instant, velocity of B, at this instant, velocity of C. So if this is rotating counterclockwise, definitely point C will be in this particular direction. So we can draw a line like this, and this is VC. Now what we need to do? We need to draw a line perpendicular to this velocity vector VC and which passes through point C. This point. Got it? Next, we need to draw velocity vector at point B. So velocity vector at point B, how will we get? We will get with the help of this crank rotation. How this crank is rotating, I'll show you the breakup of this link B, this joint B. So this is the crank and it is in pure rotation, you know, about point A. So at this particular instant, it will be moving in this direction. In this direction, with what velocity? In this direction, it will be moving with some linear velocity. We can say it VB. That will be equals to the distance AB, which is a radius in case of rotation about point A, and some omega of crank AB, and that omega is given to you and this AB is given to you. So you can write this 60 mm as 0.6 meter, 60 mm as 0.6 meter, 600 mm. Take it this as 600 mm. That will look good. So this is as 0.6 meter and omega AB is given as 10 radian per second. So we can write this VB as 0.6 into 10. That is nothing but 6 meter per second velocity of point B. This is given to you. omega is given to you. Directly they have not given velocity of point B. But once you know the velocity of point B, what you can do? You can draw the velocity vector at point B. Now look at this. As you know that point B is moving in this direction only. With the help of this crank, you can draw the velocity of point B here. And after this, what you can do? Same thing. You have to draw a line which is perpendicular to this velocity. So, how to draw velocity? Like this. We can draw the velocity. Now, where they are intersecting, look at this and tell me where they are intersecting. They are intersecting at infinity only. These two lines are parallel only. So, parallel line will intersect only at infinity. So, what will happen in this particular case? If center of rotation is situated at infinity, we can assume that this particular link is in pure translation. There is no rotation involved. So in case of pure translation, you have already seen that velocity of point B will be equals to velocity of point C. So that is already known to you, 6 meter per second. So this is our answer. Velocity of point C is nothing but 6 meter per second. Okay. So we'll finish it now. As we have seen that instantaneous center of rotation will help us to determine velocities of different points situated on different links with the help of simple concept. Okay. Thank you.